So now these first examples have us taking a look at the difference of squares pattern, which I've written right out here, that if we see a difference of two squares, we're going to factor it to be a binomial times a binomial, where the first and last terms are going to be what you square to get a squared, which is a, and what you square to get b squared, which is b. So we're going to have an a and a b in both, and one of the binomials will have a sum, and the other will have a difference. That's basically the pattern. There's not much more to it than that. So, in our first example here, we see x squared minus 49. Well, I think we can all tell that x squared is a perfect square. You get x squared from squaring x. 49, I hope you recognize that perfect square. You get 49 from squaring 7. So when we factor this, we're going to have a binomial times a binomial. And the first term in each is going to be x, because it's what you squared to get x squared. The second term in each is going to be what you square to get 49, so 7 and 7, and in one case it's plus and in one case it's minus. That's the factored version of x squared minus 49. Now remember, factoring isn't simplifying. Factoring is in effect the reverse of simplifying. So this is considered to be simplified. The factored form is not. So I just don't want you to think that anytime you see this, you have to express it this way. The only time you have to express it this way is if you're directed to factor, or if it's necessary for you to do something with that expression that involves factoring. But remember, this is not a simplified answer. We are giving this because we're directed to factor. So now let's take a look at our second one. 1 is a perfect square. You square 1 and you get 1. 4x squared is a perfect square factor. If you square 2x, square 2x, you get 4x squared. So that's a perfect square, that's a perfect square, it's a difference. We're going to have a binomial times a binomial when we're asked to factor it. The first term is going to be 2x in each. The last term is going to be 1 in each, and in one case it's plus, and in the other case it's minus. So that's all there is to factoring a difference of squares. You have to recognize the perfect squares, what you square to get the first term, what you square to get the next term. Write the two binomials, one is plus, one is minus.